now we're recording. So what I'm going to do is we're going to look at 14. And it says draw a line through all points with an abscissa of -3. Now, what is an abscissa? There's an XY coordinate, right? Everything we're graphing is XY coordinate. Well, this is called the abscissa. And that Y value is called the ordinate. Now, generally I'm not going to use abscissa and ordinate, but for the sake of reading in the book and things like that, you need to know that. If you know the words, one easy way to figure it out is, X is before Y, abscissa, A is before ordinate. So, but normally I will just say in a problem like this, draw a line through all points that have an X value equal to -3. That'd be abscissa of -3. Okay. So if we have an X value of -3, so what we'll have is we'll go back here 1, 2, 3, and it'd be everything that would be right there. And that would be a line that has X values of -3, right? You see, if we pick out any points on that line, this particular point right here is X is -3, Y is 0. This point right up here is X is -3 and Y is 2. And the point down here is X is -3 and Y is -3. All abscissa values are -3. Were you here before? Did you get? I think you can do the other problems there. Then we're going to look at 18. It says, is 2 minus 3 a solution? So it's asking, is this 2 minus 3 a solution to y equals x plus 5? What you do is for the y, you put minus 3 in, and then for the x, you'd put 2 in, and then solve that. So this would say that minus 3 is equal to 7. Is that a true statement? No. This is not true. Then 2 minus 3 is not a solution. So that's the way you do those, like 22 is saying minus 2, 0, and it's saying x plus 2y equals minus 1. So then what you do is for the x, you put minus 2, and then for the y, you put 0.
I'm sorry, are you on number 22?
24.
Oh, 24, okay.
I said 22, but I'm on
Okay.
24.
Okay.
Thanks. So then this is a minus 2 plus 0 equals minus 1. Once again, that's not true, right? This is not a true statement, so minus 2, 0, not a solution. Some of them, if it solves it, makes it true, it's a solution. If it doesn't solve it, then it's not a solution. Now, a slightly different problem that they're asking in 26 is they're saying find the ordered pair solution for y equals 4x plus 1, and then when x equals minus 1. So what you do is you go y equals 4, and then for the x, you put minus 1 in, and then solve that. Y is going to be minus 4 plus 1. I don't know why I put minus 4, it's a plus 4. Dang it. Now I know why I did minus 4, because that's what the answer was. 4 times a minus 1 is minus 4. So this is y equals minus 3. Okay, now if I've done that right, then my ordered pair solution is x is minus 1 and y is minus 3. They want the ordered pair solution. Okay? So if you have something like 32, it says y equals negative 1/6 x minus 2 when x equals 12. And then what we do is we put 12 here for x minus 2. So this 6 goes into the 12 twice. So the minus 2, minus 2, minus 4. So our ordered pair solution is x is 12, y is a minus 4. And that's what they're looking for you to do. Okay, any questions? That sense? If you need me to do any other ones so that you can do the odd problems. By the way, those people that were late, what you have to do is you have to do all the odd problems. And someone asked, do you have to do those applying concepts 45 and 46? You don't have to do those. Okay, the next group of problems are that whole page 209. That type is 33 through 40. So I'll do a couple of these types. It says graph the ordered pair solutions when y equals minus 2x and x is minus 2, minus 1, 0, and 2. So what we're going to do is we're going to have to graph it. And the easiest way to do this is to just set this thing up where you put x values here and y values here, and the x values that are given to you right there, minus 2, minus 1, 0, and 2. And then we can find out what the y values are for the ordered pair solutions, right? Okay. So then what we would do is we would put minus 2 into this thing, right up here. So we'd have a minus, and then we put minus 2 in. So that's a plus 4. And then we would put minus 1 in that. Minus 2 times minus 1 is a plus 2. Then we put 0 in. Minus 2 times 0 is 0. Then we put 2 in. Minus 2 times 2 is a plus 4. So these are the ordered pair solutions that we want to graph. So we're going to go minus 2 and a plus 4. So that should be right up there. This is a minus 2 plus 4. Then a minus 1 and a plus 2 would be right there. And then a 0 is going to be right here. And then a 2, back up to a 4. So the graphing of the answers would be that way. Any question on that? I'm going to do 40. 40 is saying y equals absolute value of x plus 1 and x equals minus 5, minus 3, 0, 3, and 5. So once again, what I'm going to do is this is my x values, these are my y values, and then my x's are going to be the ones that are given to me right here, minus 5, minus 3, 0, 3, and 5. Because I'm trying to figure out my ordered pair solutions. So what I'm going to do is I'll put into this side right here, I'll put minus 5. So it's going to be absolute value of a minus 5. I'm putting a minus 5 in for x, plus 1. So minus 5 plus 1 is a minus 4. And the absolute value of minus 4 is a plus 4. Everyone good with that? Absolute value always is the positive of the number. So then the next one is I'm going to put, for this x, I'm going to put minus 3, so it's a minus 3 plus 1, and that's a minus 2. And the absolute value of minus 2 is a plus 2. So that's plus 2. And I put 0 in, and that's a plus 1. Then I'll put 3 in, and that's a plus 4. Then I'll put 5 in, and that's plus 6. So these are my ordered pairs that I need to graph. Plot. So it's a minus 5 and a plus 4. So I'm going to come back here. 5 and go up 4. So it's right there. And then it's a minus 3 and a plus 2. And then it's a 0 and a plus 1. And then it's a 3 and a 4. There. And then that 5 and a 6 is going to be up here, kind of off of the chart up there. So this is the plots of those points. And that's the way you solve that. Okay, 42 says the amount of substance that can be dissolved in a fixed amount of water usually increases as the temperature of water increases. Cerium selenate, however, does not behave in this manner. The graph at the right shows the number of grams of cerium selenate that will dissolve in 100 milligrams of water for various temperatures in degrees Celsius. It says determine the temperature at which 25 grams of cerium selenate will dissolve. So what you have to do on 42, you have to do on the vertical axis, you're going to have to go up to 25, right? Because that's the grams. So it's going to be up there at whatever 25 is up. And then you're going to have to go over to that graph, and you notice that what is the value? It's over there, it's over at 50, isn't it? If you look at the graph, it's at 50. So for 42A, that ordered pair it's actually 50 horizontally, right? 50 degrees and 25 vertical. Now the second question is, it says at 80 degrees centigrade, how many grams? So now that B part, you're actually going horizontally 80 degrees, and the vertical is what? 5. So the problem solution is, this is the answer to A, and this is the answer to B. Correct? In terms of ordered pairs. Any questions on that? Relationships. And functions. And then want to hazard the definition of a relationship. This is just sets of ordered pairs. Okay. A relationship would be if we go teacher to student. John Staben's the teacher, you're the student, and what's your name? DJ. John Staben's a teacher. Josie. John Staben's a teacher. So if we put those groups, John Staben and DJ, John Staben and Josie, and John Staben and Trevor, that set of ordered pairs is a relation. Okay. Now the relationship could also be DJ and John Staben, DJ being X, being abscissa, John Staben being the ordinate, or Joseph. Josie, John Staben, that would be abscissa Josie, John Staben, the ordinate, and Trevor, John Staben. Those are two different kinds of ordered pairs, and would be sets of ordered pairs. I want you to keep in mind those two sets that I described, because I'm going to tell you what a function is. A function is a relation. So it says it's a set of ordered pairs, right? Because a relationship is a set of ordered pairs, right? So we got two sets of ordered pairs. One group, me first, you guys second. And the second group, you guys first, me second, right? Further definition of function, and this is for every x, and it's a relationship, and I'm going to call the relationship xy, set of ordered pairs. For every x, there is one and only one y. Now, let's think about the relationships that I just set up. The first one was what? John Staben, DJ. John Staben, Josie, and John Staben, Trevor. That's a relationship. That's a set of relationships, right? Now, is that relationship a function? For every John Staben, is there exactly one? No, that relationship is not a function. Because somebody could, this whole class then is ordered pair relationship to me, right? So if somebody said, who is the student that is in John Staben's class? Well, there isn't one. There's 20-some in this class and 20-some in another. You couldn't use it to find who you wanted by saying John Staben. Now let's go the other way around. Is the other set of functions when we have DJ, me second, Trevor, me, Johnson, me, is that a function? For every one of those people in first position, is there exactly one second person? Yeah. It just so happens there's only one second person, but each of you individually are associated with just me. For every x, there's exactly one y. That makes sense? One's a function, the other one's, but both are what? Relationships. Only one is a function. So you see, a function is a special relationship. That makes sense? Now, what we do with functions is we name them. And when you name a function, you can name a function anything you want. Now what I'll do is I'll write, I guess I'll go to the next thing. I'll write a group of functions. Now here's a shorthand way of writing functions. This just means that's just would be like if you were let's say texting somebody rather than write it out, you could do FA, right? Function. It's a shorthand way of putting it. So how do we name a function? Well, first of all, I want to show you a relationship. Y equals 2x. Now, just as a partial amount of values for x and y. I'm going to write this. If x is minus 2, minus 1, 0, 1, 2. If x is minus 2, y is minus 4, right? Minus 1, y is minus 2. So I'm just putting this x value in place of that, right? This y is 2x. Doubling function. It just doubles whatever value there is. 0, it's 0. 1, it's 2. 2, it's 4. That's a relationship, right? It's that relationship of function. Will it ever give you any value that has more than one y value? I hope you can see that is a function. That's a function. Now then, what I can do with this is I can name it. It's just like if you have a child, you name them, right? Well, this is a relationship that's a function, and you name it, right? And I could call this f. F is doubling anything that you put into it. I could also call it, if I want to, G. If you have a child, you can name it whatever you want, can't you? We could call it H. Typically, this is what you do, is you just name a function. And you can call the same, you can call different, this particular thing is a function, and you could name it f if you wanted to, 2x squared. That's a function. You just have to take my word for it. It's a function. I can name it whatever I want, right? I could call it f, g, h, whatever it is. Because there's a lot of different people in this world that name the same person, right? Same person. That's what you do. You name them. Then what you do is you add a little something here, and you tell what the independent variable is. This is a function in x. This is a function g in x. This is a function h, and you say of x. Now if this doubling function, if I had, rather than wrote it that way, if I'd have wrote it as a squared, then I would call this f of a. If I would have wrote this one, rather than f of 2x, if I'd have wrote this 2b, then this would be f of b. This is the name of the function. This is what its independent variable is. That makes sense? We'll see how it applies in a little bit. Now what I want to do, I want to take this doubling function that I had, this f of x equals 2x, that was and I want to kind of limit it down a little bit. And I want to go minus 2, minus 1, 0, 1, and 2. So this doubles it, right? So this is going to be a minus 4. This is going to be a minus 2. This is going to be 0, 2, and 4. Now I'm going to put this in a set where this is the domain. This is the range. Now what is domain and range? So all of these x's and y's, these ordered pairs, the domain are the first values. So the domain are -2, -1, 0, 1, and 2. Does that make sense? Domain, that's what it's called. It's the x values. The range is the y values. -4, -2, 0, 2, and 4. Okay? I've simply split up my ordered pairs. The first term in my ordered pair is going to be in the domain, and the second is going to be in my range. Now I'm going to do this. I'm going to associate my ordered pairs. The -2 was with the 4. This one was with this one. Now, do you notice that for every y, there's one x. For every x, there's exactly one y. That happens to be a special thing. But the most important thing for function is it says every first value has exactly one second value. Now, that occurs whenever those arrows that join them, the tail is associated with one value. I want to show you. Show you something that a function that we just did. You see, we had relationships. We had two kinds. We had JS, which John Staben, as a domain, and then we had DJ, right? Chuck Josie. JOS, that's, and then Trevor. Now notice when we said, was this a function or not a function? It wasn't a function. See what happens when it's not a function? I said, that's a function. You see there's only one tail on each one of those domain values, right? Not a function, multiple tails. If we switch those two things around and put DJ this is range, so this is domain, this is range. Now notice that's a function, isn't it? Because you see this there's only one tail on each one of those people, but on this one there's 3. That's the difference between a relationship that is not a function and a relationship that is a function. Both of those are relationships, only one is a function. Now, that being said, what we're going to do is we're going to start right over here in the front row, and you were looking at me on number 3 on that sheet. Is that a function? Not a function. It's a function. Okay. Then, I don't know, we'll say next to the wall you answered it, so now you're going to get answer 4. Is that a function or not a function? Number 4. Yep. Is it a function or not a function? It's a function. So now 5. We're going to have to go down because I don't know people's names here. Right? Just go down next to the board. Is that a function? 5?
Yeah.
Okay. 6, function. Okay, 7. Okay, does everyone agree? Okay. 8. Okay, not a function. Everyone see that? Now then, what we're going to do is the next set of problems, the way you look at those is when they're in ordered pairs, if they're going to be functions, you look at all first values of these ordered pairs. And you say, do any of them repeat? And if they repeat, do they have a different second value? So 9, go right behind the person who answered the last question, behind her next to the wall, whatever your name is.
I can't hear
Okay,
you. 8.
yeah, 9. Is that a function? Okay, now what she did is she looked at all the first values, and the first values in those ordered pairs are 0, 2, 3, 4, and 5. You see that? See, the first ordered pair is 0, 0. So its first value is 0. Second ordered pair is 2, 4. So it's a 2. Third pair is 3, 6. First, so 0, 2, 3, 4, and 5 are the first values. There's no first values that repeat. Therefore, that set is a function. Okay, the next person, 10. Is that a function? Okay, so no repeating first values. Is, try right, yeah.
What if the second repeats?
If you have a different first, you cannot have the same first value and a different second value. I'll just, if you look down there, you notice 15. You notice that the first ordered pair is 1, 1. If you go over, there's another one where it says 1 minus 2, minus 1. That makes it not a function, because for every x, for every 1, there's 2 different y's. Does that make sense? I'll show you by way of writing it out this way. You see, that one is not a function because 15 is not a function because all the first values are 1, 4, 9, then there's a 1 again, and then there's a 4 again, right? So that's domain values. So once they repeat, I don't repeat them. And then there's a range values. And the range of the second values, 1, 2, 3, minus 1, and minus 2. Now notice that 1, the first ordered pair, is associated with 1, right? The second ordered pair says 4 is associated with 2. Third ordered pair says 9 is associated with 3. The fourth ordered pair says 1 is associated with minus 1. And then the fifth one says 4 is associated with minus 2. Now, what are you seeing? That this one has 2 tails, and this one has 2 tails. Those relationships then constitute no function. Does that make sense? So anytime it's diagrammed out like that, and there's 2 tails on it, it's not a function. Anytime it's in ordered pairs, if the first value, x, repeats, and it has different second values, it's not a function. So that's the 2 ways you look at doing it. We're going to have other ways that we look at verifying that they're not functions. All right, so I guess that's